Welcome to The Explainer. Today, we're diving into a totally new kind of database that's become, well, absolutely essential for modern AI. I'm talking about purpose-built vector databases. Let's get right into what they are and the huge problem they're here to solve.
All right, let's start with a question that hits home for pretty much every AI developer out there. Your models? They're brilliant. They can understand images, text, audio, all this complex, unstructured stuff. But the moment you need to actually store and search that understanding at scale, well, your traditional database just has no idea what you're talking about. They don't speak the same language. And that right there is the fundamental shift, you know? We're moving way beyond just storing rows and columns of data. The goal now is to build systems that can search for meaning, for the context, the ideas, the concepts that are buried deep inside all that data.
And to do that, you can't just bolt a new feature onto an old system. It just doesn't work. What you really need is a completely new breed of database, something built from the ground up specifically for AI.
Okay, so let's get into our first section here. We're going to really break down the why, the core problem these new databases were created to fix.
This really paints the picture, doesn't it? Think about it. A classic keyword search for summer clothes is going to completely miss something that's described as, say, beachwear for warm weather. Why? Because the words are different. It's a total miss. But semantic search, it gets it. It understands that those two phrases mean basically the same thing. It's searching for the intent behind the words, not just the literal text.
So if this amazing semantic search is what we're after, what's the engine that actually makes it happen? Well, that brings us right to the solution and the topic of our conversation today, vector databases.
Okay, so this is where the magic happens. It all starts with something called vector embeddings. Essentially, an AI model takes a piece of data, could be a sentence, a picture, anything, and turns it into a long list of numbers. The best way to think about it is like this. Every single concept gets its own unique GPS coordinates, but on this giant, high-dimensional map of meaning. And the cool part is, things that are similar in the real world end up being close neighbors on this map.
And that's where the purpose-built vector database comes in. Now, we're not talking about your regular database with some vector features tacked on as an afterthought. No way. This is a system that was designed from day one, from the ground up, for one specific job: to handle the mind-bending challenge of storing and searching millions or even billions of these complex vector embedding.
Now, this is a really important distinction if you're building a real-world application. You might have heard of libraries like Face, right? They're amazing for the core search algorithm, but that's all they are, one piece of the puzzle. A true vector database is the whole shebang. It handles all the stuff you actually need for a production system: data management, updates, security, metadata filtering, all of it.
Okay, so you're probably wondering, how on earth do these databases find the closest matches so incredibly fast? Let's pop the hood and take a look at the core algorithm that makes this all possible.
The secret sauce is that they don't waste time looking for the perfect match. Instead, they find a good enough match, and they do it at lightning speed. This whole technique is called approximate nearest neighbor search, or ANN. I love this analogy. It's like trying to find the closest stars to Earth. You wouldn't measure the distance to every single star in the galaxy, right? Of course not. You'd use clever tricks to narrow down the search space. That's what ANN does. You trade a tiny bit of perfect accuracy for a massive gain in speed.
And it all boils down to this simple three-step dance. First, your search query gets turned into its own vector. Second, the database uses those speedy ANN algorithms to find its closest neighbors on that map of meaning we talked about. And third, it just returns the original data, the products, the images, whatever, that are linked to those neighbors. It's super elegant, super powerful, and it's how you get those amazingly relevant results.
All right, now that we've got the how down, let's do a quick flyby of the who. Who are the major players out there in the purpose-built vector database world?
So here's a quick cheat sheet for you. If you want something that's just dead simple to use, a managed service with a great API, you're probably looking at Pinecone. Weaviate is really cool for its built-in model integrations and hybrid search. If you're dealing with absolutely massive scale like billions of vectors, Milvus is your heavyweight champ. And if you need super advanced, high-performance filtering with your vectors, then Qdrant is probably the one you want to check out.
So what kind of cool stuff can you actually build with these things? Well, a classic example is image similarity search. You could literally upload a picture of a dog, and the database can find other pictures of dogs with a similar look or pose. And the amazing part is, it does this without needing a single text tag. It's literally searching by what it sees.
Okay, let's get to the most important part, right? The practical stuff. How do you actually choose the right tool for your project? Let's walk through a few key decisions you'll have to make.
So the first big fork in the road is managed versus self-hosted. It's really a classic trade-off. Do you want speed and convenience, or do you want total control? Going with a managed service like Pinecone means you can get up and running in minutes with zero ops headaches. On the other hand, self-hosting something like Milvus gives you full control over your infrastructure, your costs, your data privacy, but it's going to cost you your team's time and effort to maintain it.
Next up, you got to think about your traffic. Is it going to be spiky and unpredictable, or steady and high volume? If you're building, say, an internal tool that gets used now and then, a serverless model is a no-brainer. You only pay for what you use. But if you're building a big consumer-facing app with tons of users, you're going to want a dedicated instance. It gives you that rock-solid, predictable performance you need, even if it costs a bit more when it's just sitting there.
And finally, there's the big architectural question. Do you go all in on a specialized tool that does one thing, vector search, and does it exceptionally well? Or do you stick with what you know and just extend a general-purpose database like PostgreSQL using something like the PG vector extension to keep all your data in one place?
And this quote right here just nails the trade-off. Imagine this. You need to find products that are visually similar to a query image, but only if they're made by a certain brand and have a rating of 4 stars or higher. In a general-purpose database like Postgres, that's often just one single combined query. With a specialized vector DB, you might have to do the vector search first, get a list of IDs, and then run a second query against another database to filter them. It's totally doable, but it adds that extra step and complexity right in your application code.
Now, to counter that, a lot of these purpose-built databases have a killer feature called hybrid search. It's basically the best of both worlds. It combines that fuzzy, contextual understanding of semantic search with the razor-sharp precision of old-school keyword search. This is perfect for e-commerce, right? A user might search for running shoes for trails, but they also need to be able to find an exact product code or the brand name Solomon. Hybrid search is smart enough to merge both types of results and give you the most relevant stuff at the top.
So, we've covered a lot of ground. What's the one crucial thing to keep in mind when you're looking at all these options?
Let's wrap this up. The biggest takeaway is this. There is no single best vector database. It just doesn't exist. The right choice for you is always going to be a trade-off based on your project-specific needs. At their core, they all do the same thing. They search by meaning using embeddings and ANN search. But the one you pick comes down to asking the hard questions. What's my query rate look like? How crazy do my filtering needs get? And what are my real-world operational needs, like backups and security?
And that really is the final question, isn't it? Because choosing a vector database isn't just about picking a piece of tech from a list. It's a fundamental architectural decision about how your next AI application is going to remember, how it's going to learn, and how it's going to interact with the world. So, now that you know the landscape, what are you going to build?